So the question asks, a compound of iodine and cesium contains 63.94 grams of metal and 61.06 grams of nonmetal. How many grams of cesium are in 38.77 grams of compound? How many grams of iodine? So this question is testing you on multiple concepts. So we're going to address these in a couple different parts. The first part, we have to know what a compound is, what iodine and cesium are, and what metal and non-metal mean. So we're going to take a brief break and go to a website called ptable.com, which will define what metal and non-metal are. To answer part of this question, we need to look at a periodic table and understand how to interpret it. A nice online periodic table is ptable.com, shown here in the address bar. What's nice about this, it's interactive, so you can hover over these different regions and it will light up each area of the periodic table. So the question is asking you, a compound of iodine and cesium contains 63.94 grams of metal and 61.06 grams of nonmetal. So we're given two elements and we have to assign which one is the metal and which one is the nonmetal. So in a compound composed of two elements, the metal is typically listed first. So let's hover over the metals, and we see these regions colored in. So we look for cesium. Cesium is element 55 in row 6 here. It has an atomic weight of 132.90, so that's what that number means. And we're going to need that to solve the problem. So cesium is in the metals. It's an alkali metal in group 1 here. It's element 55, atomic weight 130, or atomic mass 132.90. So now we need to find the other element, iodine. It's going to be a non-metal. That's the other choice. It's in group 17 here, so we're going to scroll down to element 53. Its atomic mass is 126.90, so we need that number as well. So again, we can find the elements that we need, their different categories, using this ptable.com. So from the periodic table on ptable.com, we can summarize the following information that's known from the question. So let's make a table so that we can work logically through this. Iodine and cesium are elements. Elements. CS is the abbreviation for cesium. Capital I is the abbreviation for iodine. So elements have atomic masses. And we got that from the periodic table. Cesium is 132.90 grams per mole. So this is another important concept in terms of units. So grams per mole is a relationship. Notice that they're saying 63.94 grams. So gram is a unit here. So iodine is 126.90 grams per mole. So we'll have another column here, classification. We saw from the periodic table that cesium is a metal. Iodine, therefore, is the nonmetal. So what is the first part of this problem telling us? I'll write another column, given. The compound contains 63.94 grams of metal. So let's write that here, 63.94 grams and 61.06 grams of non-metal. So don't get confused in how they're wording the problem in terms of the order, iodide, cesium, metal, non-metal. You have to classify them according to the periodic table, and that's what we've done. So the compound is a combination of iodine and cesium. So what we're doing in the first part of this problem is determining the ratio of the elements. So the elements will combine in a specific ratio, and we usually call that stoichiometry. So this is nothing terribly complex. If you think of a person, one person has 2 hands, so that's a ratio. If you think of a dozen eggs, 1 dozen equals 12, that's a ratio. So what we're doing in the first part of this problem is determining the ratio of cesium to iodine. And the way we're going to do that is using factor unit conversion. Some books may call it different things, but this is how we do the calculations. We're just going to call this part 1. We're determining the ratio in the compound. So let's write metal, and then below we'll write non-metal. So we want to take the given, that's what we want to start with. The metal is cesium. We're given 63.94 grams of cesium. Now to find the ratio, because the atomic mass changes for each element, we need to figure out how many moles there are. And we're going to do factor unit conversion. So we're taking our given, and then we're going to use this atomic mass relationship. So in this process, we're going to do some algebra. So 63.94 grams. Now we need the grams to cancel out. So to do that, we're going to write the atomic mass in the denominator. So here's our relationship. 132.90 grams per 1 mole. You can think of this as 12 eggs per dozen. That's all it is a relationship. When we do this, the units of grams will cancel. So when you multiply this through, you have grams in numerator, grams in denominator, they cancel. We're going to take 63.94 divided by 132.90. That gets us 0.48 moles of cesium. We're going to do the same for the non-metal. We're starting with 61.06 grams of iodine. 126.90 grams per mole, that's a relationship. And we can express it in this form. 126.90 grams of iodine per 1 mole. And I'm writing it this way because the grams again need to cancel out. And I'll multiply this through. So when we do that, we're going to have 61.06 divided by 126.9. That gets us 0.48 moles of iodine as well. So what this information is telling us, this is the ratio of cesium to iodine. you can see that for every 0.48 mole of cesium, there is 0.48 mole of iodide. So it's a 1-to-1 ratio. And the way we express the molecular formula for this compound is the metal first, followed by the non-metal. So the compound's called Cesium Iodide. So metal, non-metal. And this is how we express it using the elemental abbreviations. So this is called a molecular formula. So in the next part of this problem, just as these elements have atomic masses, the compound is going to have a molecular weight, and we have to figure out what that is. So it's essentially the sum of the atomic masses. Because it's a 1-to-1 ratio, all we're going to do is simply add these together. When we do that, so cesium plus iodide atomic masses will get us the molecular weight of the compound. So if we sum these together, we get 259.80 grams per mole. So again, grams per mole is our relationship. And that's all it is. So think of 12 eggs equals 1 dozen. It's simply a relationship. So the compound of iodine and cesium contains 62.94 grams of metal and 61.06 grams of metal. So we've answered part 1. We've determined the ratio, and we've determined the molecular